Hey guys, so before moving on with the course, let's quickly discuss the course contents. First, we are going to discuss the time complexity analysis, in which we will discuss big O and big theta notations. Then we are going to make a nice coding layout, and I will be sharing some coding tips with you in this section. Then we are going to discuss arrays and operations on arrays and also practice problems on them. After that, we are going to move on with Kadanes algorithm, which is used to find the maximum subarray sum in a particular array. Next, we are going to discuss the binary search algorithm, which is useful to search the element in array in log n time complexity. Then we are going to discuss the number theory, in which we are going to see one important algorithm, which is Sieve of Eratosthenes. Then we are going to move on with the C++ standard template library. We are going to see vectors, queues, and stacks and important functions on them. And in the end, we are going to see the recursion concept. Okay, so these are the course contents. Whenever you feel that I am going too slow in coding implementation, you can always consider to increase the speed of video tutorial by using controls which are at the bottom of your screen. You can use any compiler which you are comfortable with, but if you are using Visual Studio Code compiler, then I would suggest installing some extensions. First, I will recommend installing C++ extension. Okay. Now, second, I will recommend installing CodeRunner extension. And the third, you can install the autosave extension, which will help you to save your code without pressing Ctrl+S or Command+S. Hey guys, in this video, we are going to discuss time complexity of algorithms. Time complexity is considered as an important factor while solving problems in competitive coding. Let's take an example. Two students, Bob and John, are learning to code in C++. They solve a problem and decide to check output of their solutions. Bob's program gives output within fraction of a second, but John's program is still running and running. That's where time complexity comes into the picture. Time complexity is an estimate of time taken by algorithm for a given input, and with the help of which we can select the best algorithm for solving a particular problem. Next, we are going to see the representations of time complexity. The first is big O notation. It is represented by a capital O with some function written inside brackets. This notation is used to represent maximum time complexity of an algorithm, which means an algorithm can have time complexity less than or equal to big O time complexity. The next notation is big theta notation. It is represented by the big theta symbol, which is often used in geometry, and it is tight bound or short time complexity of an algorithm. Here is the common efficiency order of some functions. It is seen that the constant function has lowest time complexity and the factorial of function has highest time complexity, and the other functions lie between them. Hey guys, in this video tutorial, we are going to see the meaning of big O notation. Let's consider an example in which you are given an array of 5 elements, which are 2, 4, 3, 7, and 5, and in which you have to find an element 3. Okay, that's the problem. So we'll run a simple for loop for that, in which we'll write int I is equal to 0, I less than size I plus plus, and we'll write if condition ARR of I is equal to x, so that when the element we require is found, it will print the index of that element, and we'll put a break statement which will break the loop when the element index is printed. So let's run our code. Yeah, it printed 2. Fantastic. The element 3 is present at index 2. Now let's understand the flow of code. In this code, we have an array of 5 elements. We have size of array and the element whose index we are going to find. We have a simple for loop which is for the traversal of this array ARR. and in which we have an if statement which runs for every iteration of for loop. So now let's see what this for loop is doing. It is starting from the 0th index of array. It is checking the element as 0th index, which is 2. Is it equal to 3? No. Then it is incrementing the index and checking for 4. Is it equal to 3? No. Then 3. Is it equal to 3? Yes. Then it is printing the index of 3 and breaking the loop. Now let's consider the best case and worst case scenarios here. Let's say we have to find the element 2 instead of element 3. So what do you think will be iterations of for loop to find the element 2? Yes, there will be only one iteration of for loop. Now if we have to find the element 5 in this case, this will be a worst case scenario. In this worst case scenario, the iterations of for loop will be n, and the n is equal to array size, which means input size. So always remember that the algorithms in which minimum number of iterations are constant and maximum number of iterations are equal to input size or any function of input size are defined by big O notation. Always remember that. Yeah, this was the meaning of big O notation. I hope you have understood. Let's move on to big theta notation. Okay, so now we are going to see the meaning of big theta notation. Let's consider a problem statement in which we have to print each element of array ARR. So for that, we will write the same for loop in I is equal to 0, I less than size, I plus plus, and we will write cout ARR of I in this, and ARR of I denotes the element present at particular index I. This is the solution. Let's run our code. Nice. It printed all the elements of array ARR in sequence. Now see what's happening here. We have an array ARR and we have for loop which is traversing that array and printing the element which it encounters at particular index in the sequence. Now see here, the minimum and maximum iterations of for loop here are equal to the array size or input size. So the thing to remember here is that when we get a problem statement in which we have minimum and maximum number of iterations equal to n or some function of n, such algorithms are defined by theta notation. And this is also a thing to remember. Hey guys, in this video tutorial, we are going to see some tips and shortcuts of how you can speed up execution of your code in competitive coding questions. The first one is that you should include bits header file in your code. It includes every C++ standard library so that you don't have to explicitly mention any other header file if you have included bits header file in your code. The second one is that you should add these lines in the main function of your code and then start writing the code further. This will help speeding up your IO operations. The third one is use of typedef command and hashtag define keyword. Many of the times in C++, you have used this data type long to store such a long. Now, if you have to multiply A and B, then it's a simple program, you can multiply them. That's it, you have got the output. But sometimes it can happen that you have to initialize multiple variables with data type long, and you don't have to type long again and again. So in that case, we will use typedef command and you will say for long I have to simply use capital LL, and that's it. you are allowed to use capital LL. That's it. If you run the code again, you're going to get the same output. This was the use of typedef command. Let's say you have to write a for loop to print numbers from 1 to 5. I is equal to 1, I less than equal to 5. Let's run our code. Yeah, we have got numbers from 1 to 5. But if you wish to not write all the int I is equal to 1, I less than equal to 5, I plus plus, you simply wish to write for I is equal to 1 comma 5. But how can you do it? This is where you use hashtag define and you say that I have to use only this for a comma b comma c for this full text, and yeah, you are allowed to use that. So if you write cout I and l and you have to write 6 here to get the values from 1 to 5 and run our code. Now yeah, we get this is the first output of multiplication. These are the values from 1 to 5, and these are the values which are printed by this second for loop. With the help of these keywords, you can make your code much shorter. The fourth one is setting up editor layout. This will make your work very much easier. I will show you how. Firstly, you have to paste these lines of code as I have shown in your main function. After that, you have to go to view, go to editor layout and select two columns. This will make or convert your editing window in two columns. Now you have to click on this second column, again go to view, editor layout and click split down. This will divide this entire column into two rows. Now you have to select this row and you have to put input.txt in this row. You can make this file by clicking on new file. This is just simple txt file, nothing else, and click on this row and put output.txt file in this. Okay, that's it. Now we will run a simple code in which we will take two integers a comma b and we will print out their sum. Remember one thing, that \n is also preferred over endl in competitive coding. Now we will run our code, but at this time we won't give inputs here. Instead, we will give inputs here, and let's see how it works. Yeah, nice. We have got output here. Setting up a layout like this is very helpful when you are dealing with questions having multiple test cases. Hey guys, in this video tutorial we are going to see arrays and array operations. We all know that arrays are the most basic data structures in any programming language. They are linear data structures. They store data, but the data should be of one data type, which means if you have numbers and characters, then an array can store only one of them. They store data at contiguous memory locations, which means any arbitrary element in an array is connected to its previous and next element. Now we are going to see some array operations. Our array ARR with 7 elements, and the size of array is given by int size. Now this size of operator or keyword is used to get size of any variable or data type, which means we are getting size of whole array here, and we are dividing it with the size of just one element of array, so that we can get how many elements are present in array and which will be stored in size variable. Now let's first discuss the array operation, array traversal. We will pass array and size to this function to get all the elements printed. Now we will write the function definition. So first we write data type, which a function should return. So we'll write it as void because we have to print all the elements and not return anything. We'll write function name traversal, and we will pass formal parameter array and s for size. Now we will run our for loop. So this hashtag define keyword, we have made our for loop. We will simply run our for loop, iterative variable I 0 to s. We will print the element, and we don't have to go to next line, we have to just put a space. Now I think it's all good. We will run our function, and yeah, we have got the output. Now let's discuss the further operation, which is sum of all the elements in array. We have to print sum of all the elements in an array. So we will write the data type of function. Sum will be integer, so we have to write the return type integer. Sum arr function will write, in which we will pass a formal parameter arr and size of array. So we will write this sum variable is equal to 0, which we have to increment, and we will write the same for loop I 0, s, and we will say sum plus equal to arr of I, and after the execution of for loop is completed, we'll return sum. Sum arr here, and size also we have to pass. We'll comment this and run our code to see what's output. Let's see if our array elements give some 28. 5 plus 2 7 plus 7 14 plus 4 18 plus 3 21 plus 6 27 and 28. Fantastic. Our function has given correct answer. Now let's discuss the third function, which is to search an element in array. So we'll pass array size, and let's suppose we are to search an element 2 in array. We'll write function definition. It will be void function, as we have to only print index at which the element is present. So we'll write arr formal parameter int ss size again, and int x as a formal parameter for the element 2. Again we will run a for loop I 0 to s, and we will write a if statement inside it, and we will say arr of I is equal to x. Then we have to print index at which the element is present and break the loop. So that's it. This is the function definition. We'll run the code. It has given answer 1, 2 is present at index 1. Our code has given correct answer. Now let's tackle some other operations. The fourth operation we are going to see is reverse of an array. We can simply print reverse of an array by using a simple for loop. But if you wish to make changes in actual arrangement of array, then we have to use some algorithm. Here is the pseudocode of the algorithm. First step, we will take 2 pointers. The left pointer will point to the element present at 0th index, that is first element, and the right pointer will point to the element present at last index. In the second step, we will say while left is less than right, swap arr of left, arr of right, which will swap elements which are present at relative locations. We will simply say left plus plus and right to minus minus, and our while loop will run till left is less than right. We will understand this with the help of an example. Here is the example in which we have given an array of 4 elements 1, 2, 3, 4. So according to our pseudocode, the left pointer will be here and right pointer will be here at first. Then in the second step, we will swap 1 and 4 as left pointer is less than right pointer. So we can see that 1 and 4 got swapped, and we will increment the left pointer and decrement the right pointer here. In the next step, we will swap 2 and 3 also. So you can see that 2 and 3 got swapped. So this is our answer. We will see one next solution which contains odd number of element 2, 5, 3, 7, 6. So we will do the same. Left pointer here, right pointer here, and we will swap the element 6 and 2. They got swapped. Then we will increment the left pointer, we will increment the right pointer, and we will swap 5 and 7. Now the left pointer and right pointer will be here. So the condition for our for loop will get violated and 3 is going nowhere. So this is our answer. Let's see the code for the same, and we are going to write code for the reverse of array. So we will take void return type. We will say reverse. We are going to pass our array and the int s, which we usually use for the size of array. We will take 2 pointers, left is equal to 0 and int right is equal to s minus 1, which will point to the last element of array. We will run while, as we have seen in the pseudocode, left is less than right, and we will say swap error of left error of right, and we will do left plus plus and right minus minus. But we don't have a code for this swap function. We will write this also, write the same void swap. Here we are going to use the pass by reference method, int ampersand x comma int ampersand y, and we will write int temp is equal to x is equal to y, and y is equal to temp. This is our function. We will run it. Reverse. We will pass our array size, and we have to print the elements of array, and we have to see whether the array got reversed or not. So we will write a for loop for the same array for int I belonging to array arr cout I, and we will just space separate it. Okay, we will run our code now, and yes, we have got the output. The array here got reversed. There is one recursive method for the reverse of array, which we are going to see also. We'll write the name reverse recursive, and we will slightly change the way we take arguments. So we will take int arr same, and we will take the pointers which we have taken in the previous one as arguments. So we will write the function to swap the elements which we have written here. We will write int temp is equal to arr of left, and arr of left is equal to arr of right, and we will simply say arr of right is equal to 10, and below that we will call reverse recursive function recursively, which will take the same array, but this time left plus 1, comma, right minus 1. And according to rule, we have to write one base condition in a recursive function. So the base condition here will be left greater than equal to right. So in that case, we will simply return. So this is our code. We will comment out this code and we will write reverse recursive. We'll pass array, but in the left we have to put 0 as starting index, and in the right we have to put size minus 1 as the top index of array. Here is our function. We will run. We have got the same output. Now let's discuss about time complexities of all the functions we have seen till now. The first function is traversal function. The time complexity of this function is big theta of n, as we have to traverse the entire array and see each element. The same for sum of all the array elements. We have to go through all the array elements and take the sum. The search function will have big O of n time complexity, because element we want can be found anywhere in the array or not. Swap function has constant time complexity big O of 1. The reverse function we have seen has time complexity big O of n by 2, which is asymptotically equal to big O of n. It is true for iterative reverse function and recursive reverse function. Hey guys, in this video tutorial we are going to see the practice problem 1 on arrays topic. The problem statement for the same says that find the missing number from the given sequence 1 to n. It is very easy but tricky problem. The problem actually means that we are given a sequence of elements from 1 to some n. Here the n is 7. And if you observe in this sequence or array, we can see that the element 5 is missing. As last element is 7, I have taken n is equal to 7, and we have to write a code to find this missing element. Pause the video, see if we can come up with the solution, otherwise we will solve it. Okay, we know that the sum of elements from 1 to n is given by n multiplied by n plus 1 divided by 2. And if we subtract the array sum from this n into n plus 1 by 2, we will get the missing element. Now we will code the same. We will maintain a sum variable and we will initialize it with 0. We will write a for loop which will write int I belonging to array, and we will increment the sum variable by I. You can write such type of for loop where the element indexes doesn't really matter. And we will say answer is equal to, now we will formulate the sum of first n elements divided by 2, and we will subtract this sum and we will store it in a variable answer, and in the end we'll print answer. Let's run our code, see if it works. Nice, our code has given correct answer. The element 5 is missing from the given sequence. We will discuss one more problem in the next video. Hey guys, in this video tutorial we are going to see the practice problem 2 of arrays topic. The problem statement for the same is find the prefix sum of given array elements. So here is the pseudocode for the prefix sum of array elements. It says in the for loop from index 1 to n, we are doing array of I is equal to array of I plus array of I minus 1, which means we are adding the previous index element to the current index element on every iteration of for loop. We will understand this with the help of an example. So here we have given an array with 5 elements 10, 20, 40, 60 and 50. So if we apply the prefix sum algorithm, then in the first iteration of for loop we will get 30 in place of 20, which means the element at index 0, which is 10, and element at index 1, which is 20, got added, and the sum got stored at first index. In second iteration, the element at index 1 and 2 got added, and the sum 70, which is 30 plus 40, stored at index 2. Similarly done for 60 and 70, and sum 130 got stored, and we got our answer. Ultimately, what we done here is we have added all the elements which are on lower indices than the current element index. Okay, now we will move on with the coding part of our problem. Here we have given the same array which we have discussed before. The array size is 5. Now, according to our pseudocode, we have to write a for loop. We have already made our for loop shortcut with the help of hashtag define keyword. So we will write for 1 to n. Always remember that we are iterating from the first index, as the element at index 0, which is the first element of array, is going to stay as it is. So we will simply write array of I is equal to array of I plus array of I minus 1. That's it. Our algorithm is done. Now, to check the output, we will run a for loop in which we will say int I belonging to ARR print I, and we just have to space separate it. We format our document and we will run our code. Nice, our code has given correct answer. Hey guys, in this video tutorial we are going to discuss the Kadanes algorithm. Kadanes algorithm is used to find the maximum subarray sum, and it comes under the category of iterative dynamic programming algorithms. Now, what actually the subarray means? Subarray is a contiguous part or section of an array. We will understand this with an example. So here we have an example in which we are given an array with 5 elements and some subarrays. We can observe here that each subarray element are continuous, which means the elements are one after another. We can have n multiplied by n plus 1 divided by 2 subarrays for a given array, and among those we have to find such an array whose elements when added together evaluates maximum. So here is the pseudocode for Kadanes algorithm. One more thing, that the implementation we are going to cover here is the most comprehensive, which means it is applicable even if the array contains all the negative elements. Let's discuss the pseudocode. First of all, we are initializing two variables max so far and current max, both with first element of array. And then we are running a for loop, and for every iteration in the first step we are taking maximum of ith index element and current max plus a of I, and we are storing it into the current max. And in the second step we are taking max so far, which is our global max, which we are taking with the help of max so far itself and current max. In the nutshell, in the first step we are checking whether the coming element is contributing to sum or not. We are taking maximum, and which means if it is contributing, then our max so far variable will increase if we take the maximum of max so far at current max. And in the end we are returning max so far. Let's consider an example. Here we are given an array of 5 elements, and in this array, if we observe, then we can come to know that this 2 and 1 element constitute sum which is equal to 3, and which is the maximum sum in this array. Now how can you find it? So if we apply Kadanes algorithm here and try to dry run the code, you can get a table like this, in which we have initialized current max and max so far with 1, which is the first element of array. We are running for loop. Now our for loop is here at the element -3. So according to our pseudocode, we are considering maximum between -3 and -3 plus the current max. So -3 plus 1, which is -2, and the maximum element we are getting is -2. And in the second step, we are comparing max so far and current max, which means we are comparing -2 and 1, and we are getting the maximum 1. Similarly, in the next iteration, we are at index 2 and the element is also 2. We are comparing 2 with 0, which is -2 plus 2, and we are getting the maximum element 2. And to find the max so far, we are comparing this 1 and 2, and we are getting 2 as the maximum element. Similarly, for this 1, we are getting current max is equal to 3, which is greater than 2. That's why the max so far value also increases to 3. And in the end, we have -1. So we are comparing -1 with 2, which is 3 minus 1. And we are getting the maximum 2. But this time, the current max is decreasing the sum. It is not contributing. So if we compare 3 and 2, we still keep 3 because the global maximum is higher than the current maximum. So we are getting 3 as the answer. The solution has big of n time complexity. So let's move on with the coding part. Initially, we will take an array of sufficiently large size. So we will take array of 100 elements. It will be empty array. And we will take the int n, and we will run a for loop. Here we will take elements in the array. Then as per the pseudocode, we will initialize current max and max so far. Then we will run the for loop again from 1 to n. And here we will say current max is equal to max of a of I, comma, current max plus a of I. And in the second step, as we have discussed, we will take max so far is equal to maximum of max so far and current max. And in the end, we will print max so far, which is our global maximum. We will take input. So in this array, we are going to have the same 5 elements as we have discussed while we were discussing pseudocode. 1, -3, 2, 1, and -1. Our code looks fine. Let's run our code. Nice. Our code has given correct answer, which is 3. So here in this example, if we take all the elements as positive, then we can observe that the maximum sum subarray here will be the complete array. And let's run our code. Yeah, the sum of this complete array is 8. Our code has given correct answer. And if we are having all the negative elements in our code, all the negative, then our code must return such a value which is lesser in magnitude. So our code must return -1. Nice, our code has written -1. So if our implementation of Kadanes algorithm is successful, and in the next video, we are going to discuss the binary search algorithm. Hey guys, in this video tutorial, we are going to discuss the binary search algorithm. So let's get started. Binary search is an optimized searching algorithm over the linear search. We know that in the linear search, we have to go to the place of every element and check whether the element is the required element. It is a well-known example of divide and conquer strategy. in which we divide the main problem into number of small problems and we try to solve them. Ultimately, we conquer the main problem. One more important point to remember about the binary search is that it works for the sorted arrays. And the time complexity of binary search is O of log n, which is way better than the linear search time complexity O of n. So here is the pseudocode for the binary search algorithm. In this pseudocode, first we initialize three variables. Two of them are pointers to the elements of array. The variable low is a pointer to the first element initially and the high to the last element of array. The variable mid evaluates as floor of low plus high divided by 2. The intuition behind taking the mid variable is to divide the array in two equal parts. And hence we say while high is greater than low. Now here if we see the required element x at ARR of mid index, then we return the index of that element. Else if the element x which we are going to find is greater than ARR of mid, then we shift low to mid plus 1, because we know that in a sorted array, if we are on a particular position, then all the elements on the right are greater than that element. Similarly, when our required element is less than ARR of mid, then we shift our high to mid minus 1, that is on the left hand side of mid, because all the elements on the left hand side of mid are lesser than mid. So accordingly, we decrease the size of array, check for the element in smaller range, and if we found the element, we return the index of that element. We will understand this with an example. For example, in an array, we have to find the element 14. The array contains 6 elements, and according to our pseudocode, our low will be at index 0, on which 3 is present, and high will be at index 5, on which 17 is present. Since the elements are 6, the highest index will be 5. Now to evaluate our mid, we will do 5 plus 0 divided by 2, that is 2.5, and if we take the floor of it, we will get 2. So our mid will be on the second index. Here we come to know that the element present at mid, which is 8, is less than 14. So according to our pseudocode, we will shift our low to mid plus 1. So here we shifted our low to mid plus 1. Okay, now again here if we calculate our mid, then it will evaluate as 3 plus 5 divided by 2, that is 4, and the floor of 4 is also 4. So our mid will shift to here. Now we will check that is the element at mid equal to 14? Yes, it is equal to 14. This is how we implement the binary search algorithm. Moving on to coding part, we take n as the input, which means the size of array. And then we make a dynamic array of size n. Then we run a for loop from 0 to n, and we take input of array elements. Now we will write our binary search function, in which we are going to take three parameters: our array, size of our array, and the element we are going to find. As per the pseudocode, we will declare L is equal to 0, and we will declare H is equal to size minus 1 for the last element. We will run a while loop, in which we will say while L is less than equal to H, we will declare mid variable. Okay, we declared the variable, and we will say if A of mid is equal to X, which means the element we require, we will return mid. Else if X is greater than A of mid, then we will simply shift our low to mid plus 1. Else we will shift our high to mid minus 1. Okay, and the element we are going to find is not in the array, then we will return -1. Okay, okay, our code looks good. Let's call our function cout binary search, and we will pass our array, the size of array which is n, and the x element. We will take input of x element also. So we are taken the input and we will run our code. We are using the same test case we have used while running the pseudocode. Nice, our algorithm has given the correct answer. 14 is present at index 4. Now let's check for the element which is not present in the array. Let's say check for the 9. And let's run our code. Our code should give the answer -1. Nice, our code has given the answer -1. So we are done with the implementation of binary search. In the next video, we are starting with number theory. Hey guys, in this video tutorial, we are going to discuss about prime numbers. It is a number which is divisible by 1 and the number itself. And we all know that 1 is neither prime nor composite number. So on that note, let's move on to the pseudocode to find whether a number is prime or not. So given a number n, we will simply run a for loop from 2 to the square root of n, and we will check if n is divisible by any number between the interval from 2 to the square root of n. If we find such a number which divides the n completely, then we return 0, which means n is a composite number. It is not a prime number. And if for loop ends and there is no number which divides n completely, then we come to know that n is prime number and we return 1. The time complexity of this code is big O of root n. So let's move on to the coding implementation. So we will be taking 5 numbers as input to check for the prime number. We will take a number x as an input and we will print the result written by isPrime function when number x is passed as an argument to the function, and we will print new line. Now we will write a code for the function isPrime in which we will be taking int x as an argument, and we will write a for loop as per the pseudocode from 2 to the square root of x, which we write as power of x, 0.5, and in the for loop we will be writing if x modulus I, which means the remainder after I divides x is equal to 0, which means I divides x completely, otherwise we will return 1. Okay, all looks good. We will take input 2, 4, 16, 37 and 97. So our code has given 1 for the prime number and 0 for the composite number. But if we wish to print as prime and non-prime, we will say if is prime, which means our isPrime function has returned a true value, then we will print prime, and else we will print non-prime. Okay, let's run our code for int x. Okay, our code has given correct answer. The numbers 2, 37 and 97 are prime, and the numbers 4 and 16 are non-prime. Hey guys, in this video tutorial, we are going to discuss about prime factor calculation. So what are the prime factors? They are the small prime numbers, which when multiplied together gives the actual number. Okay, now let's quickly move on to the pseudocode of prime factors calculation. So here is the pseudocode. We will initialize a variable divisor which is of integer type. We will initialize it with 2 and we will run a while loop in which we will say till the number which is given number is greater than 1, then if that number is divisible by divisor, then we will print the divisor value and we will divide the number with the divisor value itself. Else we are going to post increment the divisor. So here what we are actually doing is we are initializing the divisor value with the smallest prime number, which is 2. And if our n is not divisible by the 2, then we are incrementing the divisor. Okay, the time complexity of this code is big of log n for all the numbers except prime numbers, for which the time complexity is big of n. This is because the while loop will run nearly n times for the prime numbers. So let's understand this with the example. We have 24, then we divide it by 2, we get 12, and we are gonna print 2. And again for the 12, if we divide it by 2, it is divisible, then we get 6 and we are gonna print 2. Again for 6, we are printing 2. And for 3 is not divisible by 2. So we are moving on to the else condition and we will do divisor plus plus, and the divisor value will now become 3, and 3 is divisible by 3, then we get 1 and we are going to print 3. So the while loop condition violates here and we are going to get our answer printed. Okay, this was the pseudocode. Moving on to the coding implementation, we have to take an integer n as the input and we will call our prime factors function, which we are going to write for an integer n. The return type will be void as we are not going to return anything. We will write void prime factors here. We will take an integer divisor and we will initialize it with equal to 2. We will run a while loop in which we will say the same while n is greater than 1. If n modulus divisor is equal to 0, then we are going to print the divisor and we are going to just space separate it. And further, we are going to divide our number with the divisor itself. Okay, and in the else condition, we are going to write divisor plus plus. So we are post incrementing the divisor. Let's run it for some number 315. Our code has given the prime factors of 315, which are 3, 3, 5, and 7. Okay, let's try another example. Let's try for 45. Okay, our code has given correct answer. 3 square is 9 and multiplied by 5 is 45. Hey guys, so in this video tutorial, we are going to discuss about the Sieve of Eratosthenes algorithm. Sieve of Eratosthenes algorithm is used to find the prime numbers from any interval 2 to n. The time complexity of this algorithm is very less, which is big O of n log n. And that is why this is the best algorithm to find the prime numbers. In this algorithm, we filter out the non-prime numbers, and that is why the algorithm is called Sieve. So what steps we are going to follow? Let's understand this with the help of an example. Let's consider an example in which we are given with the numbers from 2 to 50. So in this algorithm, we are going to run a loop from the minimum number, which is 2, and we are going to say that take the square of that number, which means we have taken the square of 2, which is 4, and mark all the multiples of 2 which are greater than equal to the square of that number. We can observe in the table that we have marked all the multiples of 2 which are greater than equal to 4. Similarly, for 3, the square of 3 is 9, and this time we have marked all the numbers which are greater than equal to 9. And so on, we have done for the numbers 4 and 5 and 6 and 7. For the number 7, only 49 got marked because the next multiple of 7 will be greater than 50. Now here, if you think about considering the number 8, the square of 8 is 64, which is greater than 50, and this is our loop termination condition. So if we find such a number whose square is greater than our n, then we will terminate our loop. And here, if you observe in this table, then we will get to know that all the numbers which are not marked are the prime numbers we require in the particular interval. So let's move on to the coding implementation of the algorithm. So here we are going to take the integer n as the input, and we are going to write the function definition for Sieve of Eratosthenes. We are going to take n as the argument, and here we are going to initialize the array of sufficient size with all the elements as 0. Now we are going to write a for loop in which we will write a looping condition which will mark all the numbers from the square of that number to the integer n. So we will write for 2 to n, if prime of I is equal to 0, then we are going to run again a nested for loop in which we will say from integer j is equal to I square to n, and we will take the interval of I. That's why we have written j plus equal to I, and we will do prime of j is equal to 1. And again we will run the second for loop in which we will say for I is equal to 2 to n, if the prime of I is equal to 0, we are going to print that number, which means we are going to print the unmarked number. So we will run our function considering the argument n. Let's run our code. Okay, our code has given the correct output, which are all the prime numbers between the interval 2 to 50. Hey guys, in this video tutorial, we are going to discuss about the C++ standard template library, or the STL. Now we know that in C++, while creating certain data structures, we have to write a very long code. It's so much tedious sometimes, but C++ standard template library provides C++ class templates which help users to implement those data structures and their functions. So in this video, we are going to see the 3 most popular data structures, which are vectors, queue, and stack, which are frequently used in competitive coding. So the first data structure we are going to see is vectors. Vectors are the dynamic resizable arrays in which the elements are stored in contiguous memory location. As these arrays are dynamic, the memory allocation is only done when the new element is inserted in those arrays. The element's insertion and deletion is done at the end, and there are certain functions for that. We will discuss them. To use the vector keyword, we should add bits header file in our code. There are 3 methods which are used to create the vectors frequently. One is you can create an empty vector. The second is you can create a vector with some arbitrary size n. Okay, so we can take n and we can assign any value. Okay, the third method is to initialize all those values with some integer. Here we are considering the integer type vector. Now we will see how to add elements in the vector. The function pushback is used to add the element in the vector. So we are going to add 1 and we will replicate this line, and we will say add 2, 3 and 4 to vector. Okay, so our elements will get added when we will run the code. We will run a for loop to see whether the elements got added or not. Okay, Let's run our code. Yeah, the elements are added in the vector. Now we will see the function which is used to get the size of vector, which means how many elements are added inside the vector. It is written as v1.size. Our code has written the answer 4. Now let's shuffle the elements inside the vector and write the function to sort those elements. So first we will shuffle the elements and we are going to write a function which will sort our vector. Sorting in vectors. We will write sort and we'll write v1.begin and comma v1.end. So we are moving our pointer from beginning to end. And after sorting the elements, we will again run a for loop. The elements in the vector got printed in sorted order. The next data structure we are going to see is the queues. Queues are also the dynamic resizable container adapters and follow FIFO rule, which is first in first out, which means the element which comes first needs to be deleted first, and so the element insertion in queues is from the last. Moving on to the queues implementation, we write queue and data type int and we give it a name which is queue here. We use the push function to push the elements in the queue. Similarly, we will replicate it for some elements. We use queue.front function to get the first element of the queue. And we use queue.back function to get the last element of queue. So we have got our elements printed. The first element of queue here is 1 and the last element is 4. Now let's run the pop function single time and let's check for the front of queue. This time the front of our queue must be 2. So let's comment out the above code and check for the queue.front. Okay, we have got the front of queue as 2. We have queue.size function to check the size of queue. Here in this case we have popped one element, so the size of queue should be 3. Nice, our code has written the answer 3, which is the size of queue. We use queue.empty function to check whether our queue is empty or not. It is a boolean value, either 0 or 1. So this time our queue is not empty, so our queue.empty function should return 0. Our function has written 0. Now let's give it a try and run the pop function multiple times. Nice, our queue.empty function has given the result 1. The next data structure we are going to discuss is stacks. They are also dynamic resizable container adapters and they follow LIFO or FILO rule. That is last in first out or first in last out rule. That means the element which is inserted first needs to be removed at last. The element insertion and deletion in stacks is done from the top itself. In other words, stack is considered as a vertical array. The declaration of stack is also same. We write stack, angle bracket, and then data type, and we give it a name. Okay, now we are going to do the same. We are going to use the push function to push the element inside the stack. We use .top function to get the element which is at the top. Okay, we will run our code. We have got the answer 4. that is the element which is at the top. Okay, now we will run dot pop function which will pop the element which is at the top. Let's see what our top becomes now. Now this time our top is 3. We use the same dot size function to print the size of stack. We have popped one element, that's why the size of stack is 3 here. And we use same stack.empty function to check whether the stack is empty or not. Okay, our stack has 3 elements, which means it is not empty. Now, if you run the pop function same 4 times, which is equal to the number of elements you have inserted, then we are gonna get 1 as the answer. Hey guys, so in this video tutorial, we are going to discuss the concept of recursion. Recursion is basically known as the function call made inside the function itself. And it is also considered as an optimized approach than the iterative code, which means we write less lines of code to perform more operations. Let's consider an example in which you have to find the factorial of 5. It is 120. If you don't know what factorial is, it is simply just the multiplication of all the numbers from 1 to a particular number. In this case, the number is 5. For this, you can come up with an iterative solution like this. The iterative method says that we will write a function factorial of n in which we will declare an integer variable and initialize it with 1, and after running a for loop, we will say factorial is equal to factorial multiplied by ith element, and in the end we will return the fact variable. So this is the iterative method, but can we do better than this? That's where the recursive method comes into the picture. Let's understand that we have to find the factorial of 5. Factorial of 5 can be written as 5 multiplied by factorial of 4. So we are basically doing here that we are wrapping this part over here, and we are writing factorial of 4. Now factorial of 4 can be written as 4 multiplied by factorial of 3, and similarly for 3 and for 2. And we know that factorial of 1 is equal to 1. Now with the help of this, we will understand the recursive code. Here in the recursive method, we will write the same function for factorial, but this time we will be returning n multiplied by factorial of n minus 1. So we can observe here that the factorial function is invoked inside the factorial function itself. Let's understand our previous example. We have to calculate the factorial of 5. So when we will enter in the function at first, we will get 5 into factorial of 4 in return. Again, our function goes to factorial of 4, we will get 4 multiplied by factorial of 3. And similarly for 3, we will get 3 multiplied by factorial of 2. And for 2, we will get 2 multiplied by factorial of 1. Now comes the factorial of 1. Now we know that the value of factorial of 1 is equal to 1. So in our function, we will write a base condition which is equal to, if n is equal to 1, return 1. So our factorial of 1 will return 1. So this value will go to the factorial of 1 and it will get multiplied by 2, giving result as 2. Similarly, 2 will go to factorial of 2, it will get returned to the factorial of 2 and it will become 6. It will get returned and get multiplied by 4 and it will become 24. And similarly for 5 multiplied by factorial of 4, it will become 120, and ultimately our factorial of 5 will become 120. This was the implementation of factorial function. You can, by this idea, you can get an intuition of how the recursive method works. Okay, moving on to the coding implementation, we will take an integer n as an input and we will print the factorial function's output. Okay, now we will define the factorial function. The same parameter n, and if n is equal to 1, we will return 1 and we will return n multiplied by factorial of n minus 1 in the all other cases. So, okay, let's give input to our code, which is 5, and let's run our code. Nice, we have got the output 120, which is the factorial of 5. Congratulations, you have completed this course successfully. But remember guys, this is just the start of your journey. Keep getting knowledge, keep solving problems, and if necessary, consider watching the videos again. Now after this course, you can go to websites like CodeChef and Codeforces and try solving problems on them. Don't worry, their user interface is so easy to handle. I will also recommend a reference which is A2OJ Ladders. It is a website which contains problems from low to high difficulty level. And I will also recommend solving CSES problem set. The links for everything I will give in resources of this video. So the last words guys. Many of you can say that it is a very short course. That's right, but actually it was my first course and that is why I decided to keep it as basics. But in future, I will definitely consider making new courses which will have more content and detailed content. But this time, I just need your support and well wishes. So on that note guys, best of luck for your future. This is Shivam, your instructor, signing off. Bye bye.